part of inverses. Here we go. Problem number 2. We're now looking at the equation part of inverses. So we're moving away from the graphing for a second. We're moving away from the tables. We're talking about how to find the equation relating to the inverse. So what we did with the tables is the exact same thing we're going to do with equations. So it says, what is the inverse of the relation described by y equals x squared minus 1? So what you're going to do is switch the x and the y values. Okay, that's your first step. And it's literally just the x and the y. Don't carry any number with it. Just only switch the x and the y. So now you should see on the screen you have x equals y squared minus 1. Now this is not enough. Your next step from here is to solve for y. Okay, you have to solve for y. So we're going to take that x equals y squared minus 1 and we're going to solve for y. So we need to add the 1. And then to get rid of that squared, we take the square root of both sides. Now, you know that when you put in the radical, you have to have plus or minus. And you now have your inverse equation. So anytime you're going to solve for the inverse, switch the x and the y, solve for y. Let's look at another problem very similar. What is the inverse of y equals 2x plus 8? I have my equation. My first step is to switch the x and the y. So x equals 2y plus 8. And then my last step, I'm going to solve for y. So I'm going to subtract the 8. I get x minus 8 equals 2y. And I'm going to divide both sides by the 2. Now, we want to make sure that this looks like the equation of a line. So I'm going to rewrite this like so. Dividing by 2 is the same as multiplying by 1/2. But the reason I write it like this is because this is in slope-intercept form. This is y equals mx plus b, and that's how we will typically graph. After this problem, we're going to graph the 2 problems that we just did along with their inverse. So make sure you get your calculator out. So here we go. We just did this problem. This was problem number 2, but now they want us to graph the relation and its inverse. So if you have your calculator, that's probably going to be the most efficient, but I want to warn you of something here. You could obviously type this into y1, but right here, you have that plus or minus. Since you have that plus or minus, you have to treat them as 2 separate equations. So in y2, I would put the positive square root of x plus 1. In y3, I would put the negative square root of x plus 1. You want to keep them separate because they are essentially 2 separate equations. Now, if you can graph this without a calculator, awesome. If you want that calculator just to be 100% sure, I definitely would get that out if I were you. So when you graph these, it will look like so. You have your upward facing parabola, but then you also have, I think I made a mistake, y'all. I did this without a calculator. Whoop, let me regraph here. The vertex is at 0, -1. That's right. There we go. I got you now. I knew I made a mistake. There we go. Much more beautiful. All right, now we're in business. So what I did here was I graphed the quadratic, the x squared minus 1, and then without a calculator, I found where the vertex was, and then I just switched the x and the y like it's listed down here at the bottom, and then you were able to graph it from there as well. So you'll notice that when you have that plus or minus of a radical, that turns it into a sideways parabola, which is something pretty neat to look at. Now I want to take this a step further. I want you all to tell me if these are inverses I want you all to tell me if these are functions or not. So with the y equals x squared minus 1, does that pass the vertical line test? It sure does. So that is a function. Now remember, back from chapter 2, if you want to find if something's a function, you can look to see if the x values repeat, or you can look to see if it passes the vertical line test. So our original equation, y equals x squared minus 1, it does pass the vertical line test. However, the inverse does not pass the vertical line test. Thus, our inverse would not be a function. So we also did the inverse for this equation as well. We did it on the last slide. So in y1, go ahead and type in 2x plus 8. And in y2, we could do the inverse equation. What was it? 1/2 x minus 4. 1/2 x minus 4. So go ahead and plot both of those, and let's see what they look like together. Now that I have both those graphs, I should be able to see, without even drawing the line y equals x, that those are truly inverses of each other, and they are mirror image over that line of y equals x. So moral of this story here, if you don't have a calculator, you would have to create the table of values, or you could simply graph this linear equation from your prior knowledge. That's what I did. Or you could always create the table and switch the x and y values. It's up to you, however you want to do that. All right, this is talking more about getting away from graphing, and it's introducing the notation here, okay? The inverse of a function, f, is denoted by f to the negative 1. Now, the way that you read this is by f to the negative 1 as the inverse of f, or as f inverse. That's how you say that. The notation f of x is used for functions, but the relation inverse of f may not even be a function. And we've seen that. We just saw that on the 2 slides ago when we graphed the square root of the radical. So, when we answer these questions, we have 4 different parts here to answer. But I'm going to walk you through this first one, and I'm going to have you try the next one on your own. So it says, consider the function f of x equals the square root of x minus 2. What are the domain and range of the following function? Well, we talked about this yesterday. We cannot take the square root of a negative number. Thus, the domain here would be x has to be greater than or equal to 2. Okay. The reason it has to be greater than or equal to 2 is because we can take the square root of 0, we just can't take the square root of a negative number. Now, let's talk about the range. Since I have to plug in x, which is greater than or equal to 2, let's look at the smallest value that we will plug in. Obviously, that is 2. So when we plug in a 2, the y value that we get out is 0. If I plugged in a 6, I would get out a positive 2. So by plugging in values, I know that my range is going to be dependent upon my x values. So I know y is going to be greater than or equal to 0. If you don't believe me, you can graph it and look at that as well. However, I would make sure that you understand how to do this without a calculator because this could show up on non-calculator. Okay. So again, your range y is greater than or equal to 0 because when you plug in the 2, you get out 0. Now on B, it says, what is the inverse of f? So if I'm going to find the inverse, I'm going to switch the x and the y. But I know you're saying, it says f of x. Well, what do we know f of x equals? That just equals y. So I can rewrite this as y equals the square root of x minus 2. So now I'm ready to switch the x and the y. And now I can solve for y. So I'm going to square both sides to get rid of that radical. And I get x squared is equal to y minus 2. So my final answer for my inverse equation is y equals x squared plus 2. Now, on part C, it says, what are the domain and range of the inverse? Okay. The domain and range of the inverse, we're going to relate this back to what we did at the beginning of this section. Remember, to find the inverse, you just switch the x and the y. So if you want to find the domain and range of the inverse, all you have to do is switch your original domain and range. So you would say x is greater than or equal to 0 and y is greater than or equal to 2. All you have to do is switch the domain and range of your original equation. So last part on D is f to the negative 1, f inverse. Is it a function? Explain. So let's look at the inverse equation. Is x squared plus 2 going to pass the vertical line test? Yes. This is a quadratic and it will pass the vertical line test. There are only x values that do not repeat themselves. And there you have it. I think the hardest part here is maybe determining the domain and range of your original equation. But once you got that, you're good to go. So let's look at this next one here. If you want to stop the video, give it a try. You're more than welcome to. I will work these out, and I'll be back momentarily. You notice that this equation is a linear equation. So your domain is all real numbers, so that means your range is all real numbers. On B, it says find the inverse. Again, I'm going to go ahead and write this as y equals 6 minus 4x. I'm going to switch the x and the y and solve for y. So the reason I wrote plus 3 halves is because negative 6 divided by negative 4 gives you a positive 3 halves. I went ahead and simplified that fraction. So I have my inverse equation. On C, it says, what are the domain and range of the inverse? Well, I look at my original. They were both all real numbers. So that stays the same, even if I switched them. And then on D, it says, is this a function? Explain. Yes, this is a function. It is a linear equation. It will pass the vertical line test. I will have x values that don't repeat themselves, so this is a function. All right, this is the end of video 2. So when you are ready, go ahead and watch the third and final video.